Now, before we talked about interpolation, we looked at linear and we looked at quadratic, but we can develop the finite element model for an nth order interpolant over an element, and that's what we'll do here. Okay, so if we're gonna look at an element that has where I've used the open circles to indicate interior nodes, so the element starts at 1 and ends at n, but has some number of interior nodes, okay? And if we use this as our datum, then the position of this node position of this node is x2, position of this node is x3, position of this node x4, and so on. So if the left-hand side is A and the right-hand side is B, and we have the integral from A to B, we can take any integral and we can split it over some number of subdomains, right? So I can say that the integral from A to B is the sum of the integral from 1 to 2 plus 2 to 3 plus 3 to 4 plus. So if we just do that and write down what the equation is, so the sum is going to be over n minus 1 intervals, because if there are n nodes, there are n minus 1 intervals, right? So the sum over n minus 1 and then of course I could also write that like that. All right, so since I can just, like for what we said before, if it's the sum over the intervals, then I can just pull that sum in and write that as the integral from 1 to n. But then I have all of these jump terms, or all these terms on the boundary that have to be evaluated over each interval, right? Sorry, it's kind of a lot of writing here, but so we might rewrite that like this. All right, where Q1 is equal to that, Q2 So I'm using the x2 minus, so that's the contribution of this term that comes from the negative side. So the one that came from the interval between x1 and x2, that's the x2 minus. And then the x2 plus is the one that came from the interval x2 to x3. Okay. Now, all of these interiors these are like fluxes, right? Force flux or temperature flux, something. It's a flux, right? Depending on exactly what physics problem we're solving. Unless we have some external source, so unless at that node, at xn minus 1 or x2, unless at that node we have an external source, these are going to balance. And so they're going to be equal to 0. Right. So finally, we'll write the interval from xa to xb. And so these QJs are QJs that are external. There's some external source, right? And we'll look at this in a second.